Hello everyone. In this video, I want to talk about what it means to have the derivative as a rate of change. Now, when you start really looking at the derivative as a function itself, then it really opens up a lot of other things that you can do with the derivative. Let me explain a little bit more. So in this function fx, when you treat the derivative of the function itself, the derivative is really trying to tell us how the function is changing with respect to the independent variable, in this case x. So what the derivative is telling me when the function is decreasing, or when it is increasing, or maybe when it stays constant with respect to the independent variable x. Now, one really important area when you want to know the derivative and how things are changing is when it involves motion. So let's look at some of the key terms and derivatives for that one when you're dealing with the derivative. So motion here, so the motion is usually have some sort of function that gives you the position of the object or the particle, this gives you the height of the object or some amount of time, or it might actually just tell you where the object is located after a certain amount of time, so the position. Now, when you look at the derivative of the position, so s prime, so when you take the derivative of the position, you want to know how's the position changing over time, and this is actually giving you the velocity of the object. So the first derivative of the position will give you the velocity of the object. So how fast is it going now? You can take another derivative, so s double prime of the position, so two derivatives of your position, and you get what known as the acceleration. So the acceleration is the second derivative. Are you speeding up? Are you slowing down? What's happening? And the neat part about the acceleration is that taking the derivative of the velocity, so the first derivative, so when you take the first derivative of the position, that's going to give you the velocity, and when you take the derivative of the velocity will give you the acceleration, which is the second derivative of the position. Okay, now we're going to work with some problems that involves motion, specifically position, velocity, and acceleration. So remember that we could be looking at functions that say gives us the position of an object, like its height over time, and its derivative gives us the velocity. Let's go ahead and move on to the first example. So in this question, given the position s equal ft of a body moving on a coordinate line with s in meters and t in second, find the body displacement and average velocity for the given time interval. Find the body's speed and acceleration at the endpoints of the interval. When, if ever, during the interval does the body change direction? Okay, well, we will start with a. So this is our function here. Now, t squared minus 3t plus 2, that's the position of the function. And you want us to study these three between 0 and 2 seconds. Okay, first of all, number one, we need to find the body displacement and the average speed. So what is the body displacement? Well, it's going to be the position at 2 seconds minus the position of the object at 0. So we're going to say S2 minus S0. And that's called basically delta S. So first of all, we'll find the displacement, which is delta S. S2 minus S0. You can find S2 here, which is equal to 2 squared minus 3 by 2 plus 2. That's equal to 0. And you can find S0, 0 squared minus 3 times 0 plus 2, and that's equal to 2. So you will go here and say, which is equal 0 minus 2, and that's equal negative 2 meter. Okay? Now, that's the first part, the displacement. Now we need to find the average velocity. Well, the average velocity equal delta S, the displacement of the position of the object over the delta t, which is equal negative 2, and delta t will be 2 minus 1, 2 minus 0, which is equal negative 1 meter per second. So that's A, done. Next, we need to find the bodies, the object speed and acceleration at the endpoints 0 and 2. Okay, that's what we need to find now. So, in order to find the speed, we need to find the velocity, and the speed is basically the absolute value of the velocity. So we need to find the velocity first. So the velocity is basically the first derivative of the position, so s prime, which is equal to t minus 3. Now that's gonna be my velocity. So velocity we need to find at the endpoints. So we need to find f2, v2 and v0, which is equal 2 times 2 minus 3, that's 1. v0 we are substituting here, right? So it's going to be 2 times 0 minus 3, which is equal negative 3. So now the speed will be equal at the speed at t equal 2, at t equal 2 will be equal to absolute value of 1, which is 1. And the speed at t equals 0 will be equal to the absolute value of negative 3, which is equal to 3, of course, meter per second. So one more time, the speed is the absolute value of the velocity. Now we need to find the acceleration at the endpoints. Now, since we know the derivative of the velocity is 2t minus 3, the second derivative of the position or the derivative of the velocity will be the acceleration. So here we go. So we can say, since v equal 2t minus 3, you can take the derivative of v, and that's going to be your acceleration. So the acceleration is a constant. So acceleration would be 2 meter per second squared. Okay. Now in the endpoints, a at 0 will still be constant. Also a at 2 will equal to 2 meter per second squared. Okay. Now they are asking whether the function change its direction. Well, the function changed its direction when it was moving forward and then it came out and moved backward. So how this happened basically? If I have a graph of the velocity and the function kind of goes that way, this part is forward, this part is forward, and whatever down underneath the x-axis will be backward. Now, so the function was going forward until it reached to 0 before it goes backward. So I need to find the zeros in order to decide when the function was going forward and then it changed direction and goes backward. So in order to do that, I need to have the velocity here. So remember, the velocity was the derivative of the position, which is 2t minus 3. I need to find when the velocity will be equal to 0, and that's when the function hits the axis here. So I'm going to say 2t minus 3 equal to 0, 2t equal 3, and t equal 3 over 2. So at 3 over 2, the function will hit the x-axis, or the time axis. So if I have 3 over 2 here, I know that the velocity here equal to 0. Now I need to study the velocity to the right, the sign, the velocity here. If this is positive, then it was forward. If this is negative, then it's backward. Then it changed the direction at t equal 3 over 2. Now if this is positive and this is positive, then the function did not change its direction. Did you get it? So let's study the sign. How do we study the sign? We go to the function here and try to take any points less than 3 over 2. Let's try v0. v0 equal negative 3. So this is negative. So the function was moving backward. Let's move on to this side. Let's take, for example, number 2, v2. v2 is going to be 2 times 2, which is 4, minus 3 is 1. So that's positive. Then it was negative backward, and then positive forward. Then we will say the body changed its direction at t equal 3 over 2 seconds. Okay guys, so I'm going to be finding these 3 for the next question. So here we go. That's the second question. And what I need to find is the derivative, is the number 1, the displacement and the average velocity. So one more time, the displacement is delta S, which is S5 minus S1. So you can go here and try to find S5 by substituting 5 in here, which is going to be 25 over 5 squared minus 5 over 5, and that's equal to 0. So that's 0. And then you do same with S1, which is equal to 25 over 1 squared minus 5 over 1, and that's equal to 20. So the answer will be negative 20 meter. Now we will find the average velocity, which is V average, and that's going to be the displacement over delta t, which is equal negative 20 over 5 minus 1, and that's going to be equal to negative 5 meter per second. Okay, now what about the next? He wants us to find the let's go back just to check. He wants us to find the body's speed and acceleration at the endpoint. So we need to find the body speed. And remember, to find the body speed, you need to find the first derivative of the position. So V will be equal ds over dt, or you can call it S prime. And we will do, we need to find the derivative here, but I'm going to first rewrite it as S equal 25 t to the power of negative 2 minus 5 t to the power of negative 1 to make it easy for me to find the derivative, which is going to be equal 25 times negative 2 t to the power of negative 2 minus 1, which is negative 3, minus 5 times negative 1 times t to the power of negative 1 minus 1, which is negative 2. Now simplify, that will be negative 50 t to the power of negative 3 plus 5 t to the power of negative 2. And you can write it as negative 50 over t cubed plus 5 over t squared. Now to find the speed at the endpoints, I'll take the absolute value of v5 and the absolute value of v1, which is equal negative 5 over negative 50 over 5 cubed plus 5 over 5 squared, and that's going to be equal to 1/5 meter per second. V1 will be equal to -50/1 cube plus 5/1 squared. That's going to be equal to 45 meter per second. That's the velocity and the speed. Now, in order to find the acceleration at the endpoints, we are going to take the derivative of the velocity. So I'm going to go here and I'm going to start with this step here, and I will find the acceleration now by taking the derivative. So I'm going to say the dv/dt is going to be my acceleration, which is going to be equal to -50 times -3t to the power of -4 plus 5 times -2t to the power of -3, which is going to be equal 150/t4 minus 10/t3. Okay, and in order to find the acceleration at the endpoints, we'll find a5 and a1. By substituting 5 in this function and a in the same function, we are going to get 4/25 meter per second squared. And when you substitute 1, it will be 150/1 to the power of 4 minus 10/1 to the power of 3. And that's going to be 140 meter per second squared. Now we need to find whether the body changed its direction within the interval from 1 to 5. And in order to do that, we need to have the velocity. So just recall the velocity. It was equal to -50/t cubed plus 5/t squared. And now we need to make this equal to 0. So if you make this equal to 0, you are going to solve this part here by multiplying this by t and this by t to make it like denominator. It's going to be -50 plus 5t equals 0. When you cross multiply, you are going to get a -50 plus 5t equals 0. And you can solve this, t equal 10. At t equal 10, the velocity was equal to 0. So that's t equal 10. The velocity was equal to 0. Now we need to study the sign before 10, after 10. So, but there is something in here. If I take 10, basically this is outside my interval, right? Because my interval was between 1 and 5, right? And 10 come right after. What was the sign here? If I substitute by 1, I'm going to get, remember we substituted by 1, and we got negative sign here. So within the interval here, anything less than 10 was negative. So did the body change its direction between 1 and 5? No, because between 1 and 5, everything here was negative. And since 1 and 5 in this interval, so it's also negative. So we can say that the body did not change its direction. Okay, within the interval 1 and 5. Now, this question. At time t, the position of a body moving along the s-axis, so that's s. Time is given in second and the distance is given in meter. They want us to find the body's acceleration each time the velocity is 0, the body speed each time the acceleration is 0, and total distance traveled by the body from t equals 0 to t equal 2. Okay? Now, to find the body's acceleration, we need to take we need to find first the velocity and take the derivative of the velocity. So I can remember this is the position. If I take the derivative, that's v. If I take the second derivative, which is basically v prime, that's going to be a, right? So now we need to find v and then a. So v equal the derivative of s, which is going to be 3t squared minus 6 times 2t plus 9. That's going to be equal 3t squared minus 12t plus 9. Okay, that's the derivative, the v. Now let's try to find a now by taking the derivative of s. So a equal v prime, which is equal 3 times 2t minus 12. That's going to be equal 6t minus 12. That's a. Now, they want us to find the acceleration each time the velocity was 0. I need to find when the velocity was equal to 0. When v equals 0. So I'm going to make this equal to 0 and solve this equation. So 3t squared minus 12t plus 9 equal to 0. You can divide everything by 3, and that's going to be t squared minus 4t plus 3 equals 0. T minus 3, t minus 1 equals 0. T equal 3 or t equal 1. So at t equal 3, the velocity was 0. At t equal 1, the velocity was 0. Now we need to find the acceleration when the velocity was 0. So we are going to find A3 and A1. So A3 will be 6 by 3 minus 12, and that's going to be equal 6 meter per second squared. And A1, which is equal 6 by 1 minus 12, that's going to be equal negative 6 meter per second squared. Okay, that's the first part. Now, second part. We need to find the body's speed each time the acceleration is 0. Well, remember here we have 2, right? Remember that the velocity was 3t squared minus 12t, and the acceleration was equal to 6t minus 12. Now we need to find the speed each time the acceleration is 0. So we are going to go here and to find when the acceleration equal to 0. So I'm going to take this equation, make it equal to 0, and solve it. So at t equal 2, a was equal to 0. Now we need to find what? The speed. Well, we know the speed is basically the absolute value of the velocity at this point. So v2, which is equal absolute value of 3, 2 squared minus 12 by 2. And that's going to be equal absolute value of negative 3. That was 3 meter per second. Okay, finally, we need to find the total distance traveled by the body from t equals 0 to t equal 2. Well, think about it this way. This is my number line. Okay? At 0, at 1, at 2, and at 3. Okay, so what happened exactly at these points? At t equal 3, the velocity was 0. Okay, at t equal 1, the velocity was 0. And at t equal 2, the acceleration was 0. And of course, we start from 0 because that's our starting point. Now, what happened? I need to find the distance traveled from t is equal 0, that's my starting point, all the way to t equal 2. I need to go through this. I need to find this first and this. So what I'm going to do here, I'm going to first find S2 minus S1 and S1 minus S0. Okay, that's what I need to find. So you can find S2 by substituting here. So I'm going to write only the answer for you, and then you can try it by yourself. So S2 will be equal to 2. S1 will equal to 4. And S0 equal to 0. And again, it's only substituting in the function here up. Now you substitute here. So 2 minus 4 equal negative 2. And here 4 minus 0 equal to 4. And the total distance will be the absolute value of S1 minus S0 plus S2 minus S1. So now S1 minus S0 is absolute value 4 plus absolute value of negative 2. That's going to be 4 plus 2, which is 6 meters. Now in this question, they give us the velocity and they want us to find the body acceleration each time the velocity is 0. Well, first we need to find when the velocity equal to 0, and that's going to be t squared minus 4t plus 3 equal to 0, and you can factor that function at t equal 3 and t equal 1. The velocity was equal to 0. So if I have a number line here, I know at t equal 1 and t equal 3, v was equal to 0. And of course, when we start, we always start from t equals 0, because the first time is when the time equal to 0. There is nothing before that. Now, acceleration is basically the derivative of the velocity. So a equal the derivative of the velocity, and that's going to be 2t minus 4. Now, in order to find the acceleration at when the velocity is 0, that means we need to find a3 and a1 by substituting in the function here. That's going to be 2 meters per second squared, and we can substitute also by 1, which is negative 2 meters per second squared. Now, next step, they are asking about when the body is moving forward and backward. Well, body moving forward and backward, that's all about the velocity sign. So when the function was going backward, the velocity is negative. Function moving forward, the velocity is positive. So how we can do that? We need to test points here, here, and here. Any point. So give me any point between any number between 0 and 1. You can take 0.5, substitute it in the function here. So if you substitute 0.5 in the function, you are going to get a positive number. If you substitute a number between 1 and 3, like 2, you are going to get a negative value. And anything above 3, you will get positive. So moving forward is basically when the velocity is greater than 0, and that's basically when the time was between 0 and 1, and when t is greater than 3. Now moving backward, that's when in here, when the time was between 1 and 3. That was when the function was moving backward, or the object was moving backward. Now we need to find when the body velocity increasing and decreasing. Well, increasing and decreasing is basically based on the acceleration sign. Now, I first need to find when the acceleration was equal to 0, and then try to take points to the right and left. So a equal to 0 when 2t minus 4 equals 0, 2t equal 4, and t equal 2. So at t equal 2, the acceleration was 0. Now if you test again points from 0 to 2 and anything above 2. From 0 to 2, any point you will take like 1. If you substitute, for example, 1 here, you will get negative. 2 times 1 is 2 minus 4 is negative. So negative. If you take anything else, you will get also negative. Anything above 2, like 3, 2 times 3 is 6 minus 4 is positive. Now, the negative sign represents decreasing of the velocity, and the positive sign represents increasing. So, increasing, velocity increasing, and decreasing, velocity decreasing. Increasing when a is greater than 0, decreasing when a is less than 0. So now a is greater than 0 here, so we can say it was increasing when t is greater than 2. Anything greater than 2, the velocity was increasing because the acceleration was positive. Now anything between 0 and 2, the acceleration was negative, so the velocity is decreasing between 0 and 2. Thank you guys for watching, and see you next time. Bye.